Hi, in this video, let's find the value of x, given that you have x minus 2 in parentheses to the power of 3 equals 64. Then solution from here, we have x minus 2 to the power of 3 equals 64. So we can have this as x minus 2 to the power of 3 equals 4 to the power of 3. Then from here, let's take this to this side. We have x minus 2 to the power of 3 minus 4 to the power of 3 equals 0. So when we have this, you call that when we have a to the power of 3 minus b to the power of 3 equals as a minus b, in parentheses, times a square plus ab plus b square. So we have this to be from here, x minus 2 is our a, then b is also minus 4. Times this will be x minus 2 square. Then this will be 4 times x minus 2, then plus 4 square, everything equals 0. So we have x minus 2 minus 4 minus 6 times this will be x square minus 2 times this will be minus 4x. Then this plus 4, the expansion of this will be plus 4x minus 8 plus 16 equals 0. So we have x minus 6 times this x square. We have this to be minus 4x, then this plus 4x, it will cancel out. Then we have from here minus 4 plus 16 equals 0. So from here we have x minus 6 times this will be x square. From here we have plus 12 equals, from here we have plus 12 equals 0. Then we have to apply 0 product rule. Is either we have x minus 6 equals 0, or we have x square minus plus 12 equals 0. If we define them separately, let this be case 1, let this be case 2. So we have x minus 6 adding plus 6 to both sides. So we have x, this cancel out this, equals 0 plus 6. So from here we have x 6. And likewise happen to this, x square plus 12 minus 12 to both sides. This will be equals 0 minus 12. So we have x, this cancel out this, square equals 0 minus 12 will be minus 12. Then square both sides, we are going to have this to be x equals root of minus 12. Then when you have root of minus a equals as root of a times root of minus 1. And then let us note root of minus 1 equals I. So this will be root of minus a equals root of a times I. So from here we have x will be equals root 12 times I. And our 12 equals 4 times 3. So we have x root 4 times 3 times I. This will be root 4. This will be root 3 times I. 4 is a perfect square. 2 multiplied by root 3I. So we have this to be complex solution because of I. While we have x equals 6 to be the real solution. So this is the final answer for the value of x. So we can say to check. Remember we have x minus 2 to the power of 3 equals 64. So we want to check for x equals 6. So this will be 6 minus 2 to the power of 3 is going to give us 64. Now 6 minus 2 is 4 to the power of 3. So it's going to give us 64. Obviously from here 4 to the power of 3 equals 64, because this 4 times 4 times 4, that's what it means. 4 times 4 is 16. 16 times 4, 64. Let's 16 times 4. 6 times 4 is 24. We take 4, we leave 2 here. 4 times 4 is 4 plus 2 will give us 6, making it to be 64. So to check for the complex solution that we have in the above here, let's see. We have x